Hi folks, this is a sequence of video segments that I'm doing for solution of homework assignment number 5. Okay. Uh, the idea behind the first set of problem here is that you're given, for example, a function such as what you see number 3, and what you have to do based on what you were taught in class, you're supposed to be able to have a reasonable sketch of the graph of this function without using your calculator, and of course you can also check it with your calculator. However, the idea behind this problem is that this number 3, which one of these 6 graphs does it match? Okay, so let's actually start with number 3. Start with number 3. Where is this? Okay, so I have here f of x equal to tangent of x plus pi over 4. Okay, now when you look at it, when you compare it with the most general way that this can happen, we have tangent of k times x minus b. So in our case, k is 1 and b is minus pi over 4. So if you plotted tangent of x, k is equal to 1, remember, and then shift it to the left by pi over 4, you get the answer to what we want. All right, let's think about, first of all, in general, the period of tangent, we discussed it in class, is pi, not 2 pi, over k. And this is equal to pi over 1. For our case, k is 1. K is 1 for our case, in this case, and this is pi. So the period of this function is actually pi. Okay? Now, do we know how tangent looks like? Actually, tangent is one of the things that you should immediately realize. You can, for example, draw it, because it's one period is pi. You can draw it between minus pi over 2 to pi over 2. Okay, and the function, remember, tangent is sine over cosine. The places where the denominator, which is cosine, blows up, the function goes to infinity or minus infinity. It's an asymptote. So this tangent of x looks like this. There's an asymptote at pi over 2 and minus pi over 2 right there. This goes all the way down. It doesn't reach the asymptote. And so tangent of x is the black one. Now the red one is going to be exactly the same thing, except that it's shifted to the left by amount pi over 4. So if I go halfway between these two, it's pi over 4. So the asymptote, the vertical black asymptote, is going to get shifted to this one, and this vertical black asymptote here is going to get shifted to minus 3 pi over 4. It's pi over 2 shifted by pi over 4 to the left, and this point is going to go here, amount pi over 4, and the graph of what I want is this. Okay, so the red one is tangent of x plus pi over 4. Okay, notice that it blows up at pi over 4 and minus 3 pi over 4. When x is minus pi over 4, and you plug it in that expression, in this expression, you're going to get tangent of 0, and tangent of 0 is 0. So that is a good graph. All right. So this one goes with, let me see now, which one of these? Number 2. I think number 2, that goes with this. This goes with number 2. Okay. Very good. Let me close this and work on the second problem now. Okay, second problem is number 4 here. So we have f of x equal to secant of 2x. Let me remind you that secant is simply 1 over cosine of 2x. By the way, the graph of sine kx, cos kx, secant kx, and cosecant kx, they all have the same period, and the period is period is 2 pi over k. For our case, k is 2, so the period is pi. The period is pi. I don't want to rely on the knowledge or memorizing of what the graph of secant of x looked like. You're welcome to do that. It's just that I personally don't like to memorize it. So I know that the period of what I want is between, the period is pi. So I'm going to plot it between 0 and pi, or minus pi over 2 or pi over 2. It doesn't matter. You can plot this stuff between 0 and pi, or minus pi over 2 and pi over 2. So I will do it here. Okay. Now, let's do this thing like so. So here's x, here's y. And notice that the places where cosine of 2x is 0, you have problem. And that happens at pi over 4. When x is pi over 4 and minus pi over 4, you got a problem, because that denominator becomes 0. So we have vertical asymptote at pi over 4 and minus pi over 4. And we are plotting the function between pi over 2 and minus pi over 2 and pi over 2. Because the period is right here. This is one period from here to here. We draw it there, and then it just repeat the pattern. Now, notice that we have problem at these two vertical lines. But what I wanted to tell you is that when x is 0, you have 1 over cosine of 0, which is 1. So the function is height 1 here, and then it blows up as you approach the lines on the side. Okay. Now, when it comes to pi over 2, you plug in pi over 2, like at this point. Pi over 2, see that? At this location. Yeah, at this location, you plot you put x equal to pi over 2, you get cosine of pi, which is minus 1. So the function is minus 1 here, and then it blows up as it approaches the asymptote, and the same thing down here. Okay, and that's it. So if you wonder which one of these do these correspond to, it sure looks like this one. If you say, well, wait a minute, these two don't look alike, that's because I plotted it for you here, minus pi over 2 to pi over 2. I did this piece for you because this is minus pi over 2 and this is pi over 2. And that matches this, and then you keep repeating itself, keep repeating it, and then you get exactly what's down here. So this number, this particular problem, this one matches that guy, number 3. Okay, so let me close this, open it up again to do the next problem. And the next problem is number 5. So number 5, and I can tell you there is a problem in the book. There is, well, let's find out. There may be a mistake in the book for this one. We'll find out. Draw. Okay. So what I have here is f of x equal to cotangent of 2x, which incidentally for my information is cosine of 2x divided by sine of 2x. This is helpful for me because it tells me when the denominator is 0 right away. Okay? So, first of all, so this is cotangent, not cosine. Cotangent, right? So the period of cotangent, here's your value k. The period of cotangent is just like tangent, and that is pi over k. Okay, because k is 2, you get pi over 2. So the period of this function is pi over 2, and the choice is yours. All you have to do is to make sure that whatever you plot is between an interval whose length is pi over 2. So I will do that I will do that between 0 and pi over 2. That'll be fine with me. So let's see. Let's go here. So when the denominator is 0, this is the denominator. And that happens when x is 0, sine is 0. And when x is pi over 2, down in the denominator, you have sine of pi, which is also 0. So definitely, we've got problem at these two locations. So 0 at the location 0, and at the location pi over 2, we have problem. Okay? Now, what we can do is try a few more number, because this graph is going to be very similar to tangent graph. Very similar to it. But I don't want to necessarily memorize all of these. So what I'm going to do is I'm going to try a few numbers. For example, what about pi over 4? Let's try pi over 4 here. When you put pi over 4 in this expression, or you put in your calculator cosine of 2 times pi over 4, you see that you're going to get 0. Okay? When you put, for example, a different number on this side, let's hypothetically say pi over 6. And you put this thing in your calculator, cotangent of 2x, or you actually put it in cotangent of 2x, 2 times pi over 6, which is cotangent of pi over 3. We know that this is cosine of pi over 3 over sine of pi over 3, and these are numbers that you should know. You don't have to have your calculator to do that. This is 1/2, and this is root 3 over 2. The point is that it's a positive number. So at this location, we have a positive height. So the graph of the function is going to be coming from infinity, going to 0, and then going all the way to infinity. So this is the graph of cotangent of 2x. Now, which one does it match? The problem is that it doesn't match any one of these, because if this pi over 4 was intended to be that location, then it would be okay. But the way it's printed in the book is that it looks like it's the location of the vertical line. That is a mistake, okay? So this pi over 4 that you see here should be referring to that location. And if that is the case, then it matches whatever we got here in this drawing. All right, folks? So this is the, where was it? Yeah, this number 4 is the answer to what we have here, cotangent of 2x, okay, cotangent of 2x, except for that correction that I made in the graph. Let me close that. Let's go to the next one. All right, so there, tangent minus tangent of x. Now, if you know the graph of tangent of x, because you have minus tangent of x, all you do is you mirror it with respect to the x-axis. Okay, this is stuff from what we did last week, section 2.3, and what was done in your 105 course. Now, remember, tangent looked like this. Tangent looks like that. This black one, the black one is tangent of x. If you mirror this thing because of that minus sign, you're going to get this guy minus tangent of x. So the red one is my answer. Just to make sure that you can see it better, I'm going to delete this. So let's see now which one does it match. By the way, it goes through this point. Okay, so this one matches number 1, right there. It matches this. Okay, remember, this is pi over 2, this is minus pi over 2, and this is 0. All right, folks. So let's go to the next problem. Next problem is number 7. What do we got here? So draw number 7, f of x equal to 2 secant of x. And let me remind you that this is 2 times 1 over cosine of x. All this 2 does, this 2 in the front of the secant, all it does is stretches it in the vertical direction by a factor of 2. So if I know how secant looks like, all I do is stretch it in the vertical direction. Now, first of all, let me remind you that k is 1, period is 2 pi over k, and the period is 2 pi. So all I have to do is to plot this function secant between, for example, minus pi and pi. That's the 2 pi interval, and then stretch it by a factor of 2. Okay, let me remind you the denominator. When the denominator is 0, you got a problem. So you have a problem at pi over 2 and minus pi over 2. You have a problem here. There are these vertical asymptotes right there. Okay, and let me also remind you that when you look at secant by itself, don't worry about the 2. Secant of 0, which is 1 over cosine of 0, is 1. So the graph of secant, when we did it in class, it looked like this. And then when x is, for example, pi, 1 over cosine of pi, 1 over minus 1, so it goes like that. So this black one, this black curve that you see, the black curve is secant of x. But what I have is 2 secant, of x, which means everything is stretched by a factor of 2. So this point, which was height 1, now it goes to height 2. Of course, you shoot to infinity, like this. Okay. This one that was height minus 1, this is height minus 1, it goes to minus 2. Goes like this. It goes to minus 2. And same thing down here. So this red one is the graph of 2 cosine of x. Now, if you compare these, you will see that it matches number 4. Number 4 is right here. See that? And again, the reason that they look different is because I plotted only this piece for you. This piece, I plotted this, and then it repeats itself to the left and to the right. Okay? Now, there are 2 more. The final problem is what here is 1 plus cosecant of x. Let me close that. Start it again. Okay, so this is number 6. Number 6 is 1 plus cosecant of x, or simply 1 plus 1 over sine of x. The only reason I did it like this is because if you know how this thing looks like, then all you do is you shift it up by 1 unit and you're going to be set. So let's concentrate on cosecant of x, which incidentally is 1 over sine of x. The period is 2 pi. Period of sine is 2 pi. And therefore the period of cosecant is 2 pi. So I can plot it between minus pi and pi. This is a total length of 2 pi. You could have done it at a different interval, 0 to 2. If you want, you can do it between 0 and 2 pi. It doesn't matter. As long as I do it in one period, and this is one period, this is 2 pi. I know some of you don't believe it, but look, from minus pi to pi, it's length of 2 pi. Okay. Now, so when the denominator is 0, we have trouble. And of course, trouble means that when x is 0, let me draw the troubled line with a different color. How about doing it with green? So this is a trouble line because x is 0, sine is 0. This is a trouble line, and this is a trouble line. It means asymptotes. Okay. So let us go back and plot the 1 over sine. Okay. Now notice that when x is pi over 2, no problem. The value is the value is 1. Like this height is 1. When the when x is minus pi over 2, you plug in here in the sign 1 over sine of x, you get minus 1. So it goes like this. This is minus 1. So the graph, actually the graph of cosecant looks like this. Oh, wait a minute. Let's try it again. The graph of cosecant looks like that. Now, because we are interested in 1 plus cosecant, this whole thing is shifted up by 1 unit. Shifted up, right? So this point goes here, the red one, goes down. This one goes here. These asymptotes are still holding. So 1 plus cosecant of x is the red one. So in fact, when you compare it with these graphs, that goes with number 6, with this one. And as I said, if it looks different from what you see there, because what I have drawn for you is this portion. I've drawn for you this portion. Okay. This is the piece that I've drawn for you between minus pi and pi, and then repeating. Just look, that's the same thing. Okay. All right, so this video segment took about half an hour, maybe 35 minutes. And yeah, it's you've got to put some effort into this, please.